Well, let's do two problems. What if we have A ORed with A ANDed with A not? Can we simplify this? The answer is yes. How could you do that? Well, take out the A, that's a common factor, here and here. Take out A. A times what will give me this? Will give me A. The answer is 1. Now I'll bring down the OR, like so. Now, A times what? How do we do that again? A times what will give me A not? And the answer is A not. A times A not will give me A not. And there we go. We've got our simplification. Can this be broken down any further? Yes. You have a 1 ORed with a not. If you have a 1 ORed with anything, what is going to be your output? The answer is 1 all the time. If A not is 0, 0 or 1 is always a what? A 1. If A not is 1, 1 or 1 is a 1. Wow. So now, this simplifies to A ORed with A ANDed with 1. Now, wait a minute. If you have a and a 1 here, and you AND anything with a 1, what is your output always going to be? Well, if A is 0, and you AND that with a 1, 1 and 0 will be a 0, which is what A is. But what if A is 1? Then 1 and 1 will yield a 1, which is what A is. So your output will always be A. So this expression simplifies to A. What do you know? Alright, a moment ago I said A or A and A not is the equivalent of A. Let's put that to the test. I'm going to draw the circuit. Here's my switch, A. I'm going to need an OR gate. I'll put that there. I'm going to take A. I'm going to OR it with something. A ANDed to A not. So I'm going to need an AND gate here. And let's connect A to this AND gate. And I'm going to need an inverter. Let's put that there. And connect A to the inverter to get A not, and then the inverter to the input of the AND, and then this AND output to the OR gate. Then let's put an LED here, like so. So this is this switch, A OR, A and A not. Here's A, and it's ORed with this guy here, which is A and A not. I'm going to move this over just a little bit If I can get some space, like so. I'm going to connect this to a separate circuit. I'm just going to connect this to the switch, so you can see what A is all the time. So A shows up here. A is also going to be ORed with A naught. So this output and this output should match all the time. If these are equivalent circuits, if A ORed with A and A naught is really equal to A, then these two should always match. Let's run the circuit and find it. Okay, both circuits, the LED is off. I'm going to switch this to on, and both of them turn on. Shut it off, both of them turn off. These are equivalent circuits. A or A and A naught is the same as A, just as we logically showed it to be. Thanks for listening. I'll see you in the next video. Bye-bye.